Cougars. Today we're going to be adding pages 9 and 10 to our ISN. You can see that I've got my table of contents open and I've added pages 9 and 10, Powers and Exponents, and today is October 12th, 2021. So I'm going to turn over to pages 9 and 10. And you can see that I've already got myself set up. And this is what you should do first, is that you should make sure that you have the page numbers. 9 should be on the left, 10 should be on the right. If for some reason your numbering is off, skip a page so that you can start over and rewrite 9 and 10. So you've got 9 on the left and 10 on the right. I've titled the page Powers and Exponents, and I've put the date in the middle there. There's 2 handouts that you're going to get for these notes. The first one is going to be a colored sheet of paper. Today I have yellow. And so how we're going to get this one set up is we are going to fold it in half, and then we are going to fold it in this top bark part we're going to pull back and fold that part in half, but so that it creates kind of like an accordion that you pull out. And so I'm going to glue that to page 10, and the other thing we're going to be gluing in is this exponents doodle sheet. And so I am going to ask you to pause the video, get your supplies, fold them, and get them fixed onto pages 9 and 10. So now I have glued in, and I did choose glue today, my exponents doodle sheet and my blank yellow piece of paper that's been folded like an accordion. I see a spot that I might want to touch up right there. But you're also going to notice that I have filled out a chart just down below here. And so I'd like you to pause the video and take a moment to create a chart like this. And so what I did is I wrote, and of course I recommend using pencil first and going over it with a pen after, just in case you make an error you can erase. Reading exponents, and I left a nice big space for words, multiplication, power, and value. So pause the video and fill out your chart to get it ready for some. So on the left-hand side here, I have a doodle sheet for you. And the first thing that you're going to want to do is put your name in the upper right-hand corner because there's a spot for your name. So I'm going to put Mrs. Stevens. And let's just go ahead and jump in. Right here, it says when you first learned multiplication, you probably represented multiplication using repeated addition in groups. Basic exponent operations can be represented by the repeated multiplication. And so I'm going to write the word multiplication here. Okay, and you could highlight that if you want. So maybe I'll use a little blue or not. It's your choice on how you want your notes to look. For me, color helps me process my information better. So when you see that, you've got 4 with an exponent of 3. Well, what does this mean over here? Let's come over here to this example here. B stands for our base. And so I want to write that in down here because there's my arrow. Base. And I think I'm going to use blue to kind of add some color to that. So B stands for base. Oops, backwards. That is the number that we are going to repeatedly multiply together. This N up here, the title of that is called exponent. So the base is being raised to an exponent. So this means that b multiplied by itself n times. So I'm going to oops. Oh goodness. That is my error. And that's why you should use pencil, ladies and gentlemen. I am going to have to get some white out. All right, I switched it out for a different one. So when we have b to the exponent of n, what that means is that b is being multiplied as a factor n times. So let's put that into some examples here. I've got 4 with an exponent of 3. So see how I've got 4 times 4 times 4 represented 3 times to equal 64? Well, let's look at the next one here. 1 to the exponent of 5 is 1 times 1 times 1 times 1 times 1. Well, that's a pretty easy one right there. We know that it's just going to be a 1. Well, let's look at this example here. 3 with an exponent of 2. Well, before we move on, I want to remind you that we can say an exponent out loud. We call a number with a power of 2 squared. And also a power of 3 cubed. So 4 cubed is 64. 3 squared is going to be represented by 3 times 3, which gives us a 9. So a couple more things to consider over here. Let me see if I can zoom in for you. Any number to the 0 power is 1. Any number. Any number to the first power is itself. And powers of 10 are only going to contain ones and zeros. And there's some patterns there that we're going to be able to observe. So let's take a moment to try it. And I'm going to switch over to using a pencil just in case I make another mistake here. I want to follow my own advice here. So 2 to the power of 5. Well, let's go ahead and write that out as multiplication. So I'm going to write a 2 5 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And all of these are positive integers, so it gave me a positive 32. 5 cubed. Well, I'm going to write 5 3 times. I'm going to write it as a multiplication problem in an expanded form. 5 times 5 is 25. 25 times 5 is 125. 10 cubed is 10 times 10 times 10, which gives us 1,000. Notice the pattern here. How many zeros there are in the multiplication and how many zeros are in our product. Number 4, 12 to the first power. Well, we said over here that any number to the first power is itself, so it's just 12. Number 5, 10 to the fifth power. 10, 10, 10, 10, 10, and I don't think I'm going to have enough room to write that, so I'm going to write it down here, and there's 2, 3, 4, 5 zeros there, which means my comma goes there. I've got two different periods there, the hundreds and the thousands. 10 to the power of 5 is 100,000. And notice again here that the powers of 10 will only have ones and zeros. And so the pattern that we've seen is if I have 10, and this only works with powers of 10, raised to the exponent of 3, there are 3 zeros in my product. Raised to the exponent of 5, there are 5 zeros in my product. 10 raised to the power of 13, I'm going to have 13 zeros, and I'm going to have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I'm going to go every 3 to put my commas in, and we have quite a large number there. So there's a couple of things that you want to be cautious of. And I'm going to move this up here. You want to beware. The base is only what is directly in front of the power. And so I'm gonna actually show you what I encourage with these doodle notes. I left bubble letters there because I want you to doodle in them. Don't ruin the integrity of the notes, but make them colorful, make them fun, make them pop. And so on camera here, it doesn't look as great as it does in person. Maybe if I go like that. So since the base is only what is directly in front of the power, in order for a negative symbol to be included in the base, it must be grouped with parentheses. And this is something that we talked about quite a bit already. So notice that the negative symbol is not a part of the base here because it's not directly in front of our exponent. So the negative is outside of these brackets, which are holding this multiplication together. We're grouping 2 times 2 times 2 times 2 together, and the negative sign is outside, waiting to see what happens. When we have the negative symbol inside of the parentheses, like we have here, it is part of the base. Because of the parentheses, you are including it. So -2 times -2 times -2 times -2 is a positive 16. And that's definitely something that you want to keep in mind. So let's go over here to page 10 and add some more ideas about this to make it really plain for us. And so this accordion is where we are going to start. So I want you to make sure that you are using a pencil, and you can see that this is where that fold is. Maybe I'll draw a little line to make it visual on here. And I want us to make a medium-sized 2. I guess that's pretty large. And we're going to raise it to the exponent of 4. So this 2 is our base. This 4 is our exponent. This whole thing, 2 raised to the exponent of 4, is what we call a power. And so we are going to make an equal sign that crosses over that barrier. And I know that, oh, did we do that one over there? We didn't do that one here. We did it the other day, which is why I chose this one. Our answer is 16. Okay? So this is what it looks like when you just have the expression or the power and our product, our answer here. But let's go ahead and open this up. And I'm actually going to add equal sign to that. And I want to write that as a multiplication problem. So I've got 2 times 2 times 2 times 2. And I wanted to do that 4 times. 1, 2, 3, 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that you have that example right out in front. And so I'm probably going to go back when this video is over and use color to both page 9 and 10 to make this pop a little bit more. The last thing I want you to add to your ISN are some examples of how to read an exponent. So let's do our power right here. So we'll start with 3 to the exponent 1. And let me switch over to a different marker. So 3 to the exponent 1. And what you're going to say with this in words is 3 to the first power. And so I'm going to write 3 to the first power. And what that looks like as a multiplication problem would be, we know any number to the first power, it's only going to be represented one time, which means it's going to be itself. And so this is what it looks like as a multiplication. Our power is going to be 3 to the first power, and our value is going to simply be a 3. I guess that was a bit redundant right there. Let's look at one more here. Let's do 5 cubed. Oops, I guess I can use the same color here. So I'm going to show you the power, 5 cubed. And what that's going to look like as a multiplication problem is just like what we saw over on the other page here. We've got 5 times 5 times 5, and we know from over on page 9 that that is valued at 125. And what I'm going to say in words here is 5 cubed. So I'm going to give you a couple more examples that you will be able to add on to here, and you should pause the video and add them to your own. So you can see that I've added a couple more examples here, which you should pause and add to your own ISN. And I've also gone ahead and added color to my accordion example here, just to make it more visually pleasing. So I hope you find this helpful. Reach out if you have any questions.